MS Ramaya University of Applied Sciences.
Hi students, let us have a discussion on op-amp inverting and non-inverting amplifiers. The aim of this experiment to observe the output waveform for the inverting and non-inverting amplifiers and to design a inverting and non-inverting amplifier for required gain. Motivation to this experiment. Amplification finds many applications in day-to-day life. Weak signals from transmitters can be amplified and can be received without any errors. So, it is used in transmitters and receivers of communication systems. It's used in healthcare devices. Let us understand the theory behind the experiment before conducting it. Op-amp inverting amplifier. It provides 180 phase difference between input and output. Gain is given by the ratio of V output by V input, which is equal to minus RF by R1. Op-amp non-inverting amplifier. Output is magnified form of input without any phase difference. Gain is equal to V output by V input, which is equal to 1 plus RF by R1. To conduct this experiment, we need dual DC power supply, design values of resistors, op-amp MUA741, function generator, digital oscilloscope, breadboard and connecting wires. Figure shows the pin diagram of op-amp IC741. Figure shows the circuit diagram of op-amp inverting amplifier. Here, input is applied to the inverting terminal of op-amp IC. Experimental setup is made as per the circuit diagram. Apply the input of a 1 volt peak to peak 1 kHz AC signal from function generator to the circuit. Connect oscilloscope probes across the input and across the output. Observe the waveforms on the oscilloscope screen. Measure the input and output waveform. Tabulate it and calculate the gain. Figures show the experimental setup, breadboard connection and waveforms of an inverting amplifier on oscilloscope screen. Figure shows the circuit diagram of op-amp non-inverting amplifier. Here, input is applied to the non-inverting terminal of op-amp IC. Figures shows the experimental setup, breadboard connection and waveforms of a non-inverting amplifier on oscilloscope screen. Expected waveforms in the figure gives a comparison of output waveforms of inverting and non-inverting op-amp amplifier. Limitations of the experiment. Input voltage can't be applied more than a voltage Vmax, where Vmax is equal to the ratio of op-amp saturation voltage and gain of amplifier.
Hello students, name of the experiment is op-amp inverting and non-inverting amplifier. Aim of the experiment is to study the characteristics of a inverting and non-inverting amplifier and also to find a gain of op-amp based inverting and non-inverting amplifier. Components required for the experiments are function generator. This is function generator. It is used to apply the sine wave as a input to the given circuit. Connecting wires. These are connecting wires which are used to connect the different components on breadboard. Dual DC power supply. This is dual DC power supply. It has two DC power supplies. One is this one and one more is this one. Each power supply has two terminals. One is positive, that is red in color. One is negative, that is black in color. This DC power supply voltage we can set by using these two knobs. One is coarse, one is fine, and current can be set by using this knob, and same set of knobs and terminals are there for another power source. This power supply is used to apply a plus VCC and minus VCC in a op amp. Breadboard. This is breadboard. It is used to connect different components on it. Op amp. This is mu A741 op amp IC. So this is a 8-pin IC. It has 8 pins. One side it has 4 pins and other side it has 4 pins. On the top of it you find a one notch. Just beside a notch there is a one dot. The dot indicates that pin is pin number 1. For example, this is a pin number 1. Next to this is pin number 2, 3 and 4. Pin number 1, 2, 3, 4. So one side it has 4 pins, and opposite to pin number 4. So other end of this like this. So opposite to pin number 4 is pin number 5, pin number 6, pin number 7 and pin number 8. And as we shown in a IC diagram, for a 741 IC, pin number 2 is negative terminal, or it is called an inverting terminal, and pin number 3 is non-inverting terminal, or it's a positive terminal, and pin number 6 is output terminal, pin number 4 is minus VCC, pin number 7 is plus VCC. Resistors having value 1K, 5K, 820 ohm. This is 1 kilo ohm resistor. Its color code is brown, black, red. This is 5.1 kilo ohm resistor. Its color code is green, brown, red. This is 820 ohm resistor. Its color code is violet, red, brown. Digital oscilloscope. This is digital oscilloscope. It is used to measure and observe any waveform in a circuit. And probes. These are probes which are used to connect oscilloscope to the breadboard as well as a function generator to the breadboard. Let us start the circuit connection of a inverting amplifier based on a given circuit diagram. Let us take a IC741, which is op amp, connect on a breadboard. If you connect like this on a breadboard, this is pin number 1, pin number 2, pin number 3, pin number 4, and this is pin number 5, 6, 7 and 8. Now based on the given circuit, pin number 2 is connected to the resistor 1K. So take a 1 kilo ohm resistor. This is a 1 kilo ohm resistor which is connected to pin number 2, and another end of the 1 kilo ohm resistor is connected to input voltage V in. So this is a function generator which we are using to apply the input for a given circuit. So to make a connection, let us take a probe, connect to function generator. So here it has 2 channels. You can use any one channel, and this is the red which is called positive, black is negative. Based on a given circuit, the input is connected to 1 kilo ohm resistor. So I will take a positive input, take a wire, connect to positive input and connect it to a 1K resistor one end. And negative of input is connected to ground. Take a wire, connect to this probe negative which is connected to ground. Let us consider this bottom part of the breadboard. That is first row I will take as a ground, connected to ground. Next, pin number 3 is connected to 820 ohm resistor. So let us take 820 ohm resistor. This is 820 ohm resistor which is connected to pin number 3. So here is a pin number 3. One end is connected to pin number 3, and another end of 820 ohm resistor is connected to ground. So as I told, this row is a ground line will connect to ground. Now the resistor 5K is connected between pin number 2 and pin number 6. So here is a pin number 2. I will connect one end to pin number 2, and another end of 5K is connected to pin number 6. You see the breadboard here, this is a 4, 5 and 6 connected to pin number 6. Now we will connect plus VCC and minus VCC by using dual DC power supply. So to connect that, what I will do, I will use this source. This is called plus VCC. I will connect it to pin number 7 based on a given circuit. So here is a pin number 7, and here we have two sources. The negative of first source I will short with the positive of second source to get a plus VC and minus VC. Short like this. And I will take one more wire. Either I will connect this part or this part to another the same. Now this shorted end is connected to the ground in a circuit. So this is a ground line. I will connect to ground. Now this is plus VCC, which I have already connected to pin number 7. Now this is minus VCC, which is connected to pin number 4. So I will take a wire, connect to minus VCC. Which is connected to pin number 4. So here is a pin number 4. Now we need to connect a digital oscilloscope so that we can observe and measure the output voltage. So in digital oscilloscope we have two channels. So one channel I will connect to input, take a probe, connect to channel 1. Again it has two ends. This is called positive and this is called negative. So I will connect channel 1 to the place where input is connected. So channel 1 positive, take a wire and connect to this positive and connect to the input. So this is the input. So here is the positive of input. So I will connect channel 1 to the positive of input. And I will take one more wire and connect to the negative of this probe, which is connected to ground. So here is a ground line. So this is how I have connected channel 1 to the input. Similarly, you take one more probe, connect it to channel 2, which is connected to output. If you see the circuit, output is taken from the point or a pin number 6. So this is the positive of probe 2 or channel 2. So I will connect to pin number 6. So this is pin number 6 and its negative is connected to ground. Take a wire and connect it to ground. So now we have done a complete circuit connection for a op-amp inverting amplifier. Now turn on the function generator. And apply input as sine wave having an amplitude of 1 volt peak to peak. So go to amplitude, apply 1 volt VPP, and frequency, go to just frequency, apply 1 kilohertz. So now we have set a sine wave of 1 volt peak to peak and 1 kilohertz frequency. Just on this. Now turn on the DC dual power supply and apply both source are set, both voltage source value as 12 and 12. So the first source I will make 12. Similarly make the second source voltage also as 12. Now turn on digital oscilloscope. Now go to default setup, then auto set. Now you can see two waveforms here, one is channel 1, one channel 1. So just combine these two and bring the channel 1 waveform to the reference line. Similarly channel 2 waveform also to the reference line. So now you see that the yellow color signal and light blue color signal both are a sine wave. Difference is the channel 2 signal is having opposite phase as the channel 1 signal has. So let us measure these signals. So channel 1 signal, as we have connected channel 1 to the input, so it is the input voltage. Its voltage is, it's covering 2 blocks. 2 into 500 millivolt equals to 1 millivolt. So this is Vin. Vin is equals to 1 volt peak to peak. Let us note down this reading in a given tabular column. Similarly, we will measure the output. So off the channel 1 and on the channel 2. Now if you see this is a channel 2 waveform, I want to measure it, so just change this scale so that I can measure easily. Now if you see, it's covering totally 1, 2, 3, 4, 5 blocks. So 5 into 1 volt. 5 into 1 is 5. So output voltage is 5 volts peak to peak. Note down this voltage also in a given tabular column. Now we have finished the circuit connection of op-amp based inverting amplifier, and also we have noted input voltage and output voltage in a given tabular column. Based on these readings, we will do the calculation for a practical gain and theoretical gain. Let us start the circuit connection of op-amp based non-inverting amplifier based on a given circuit diagram. This is the circuit connection of inverting amplifier. Now I want to connect a circuit for non-inverting amplifier. If you see the circuit diagram for inverting and non-inverting amplifier, there is a small difference. In inverting amplifier, input is applied to 1K and 820 ohm is grounded, whereas in non-inverting amplifier 1K is connected to ground and 820 ohm is connected to input. So I will do the corresponding changes here. So this is 1K. Instead of connecting to input, I will connect it to ground. And this is 820 ohm. Instead of connecting to ground, I will connect it to input. Now this is a circuit connection for a non-inverting op-amp based amplifier. Turn on the function generator. Apply input as sine wave, amplitude 1 volt, 1 VPP, and frequency 1 kilohertz. And on this, now turn on the DC dual power supply. So before turning on, make its voltage to minimum value and current to maximum value. And now we will set both source voltage as 12 volt. Make it 12 volt by using this knob. Similarly, second source, which I will just set as 12 volt. Turn on the digital oscilloscope. So just go to default setup, then auto set. Now we are getting two waveforms. The channel 1 is an input waveform. Just merge these two. Channel 2 is a output waveform, and bring it to reference line. If you see the input and output waveforms, both are in same phase, but output is more than input. Let us measure the input voltage and output voltage. As we know that channel 1 is connected to input, so just on the channel 1, off the channel 2. So this is a channel 1 signal which is covering two blocks, each block having a value of 500 millivolt. So 500 millivolt into 2 is 1 volt. Note down this value as Vin equals to 1 volt peak to peak in a given tabular column. Similarly, measure the output voltage that is coming through the channel 2 on the channel 2. If you see, this is the output waveform, so I will maximize the scale. I can measure easily. And if you see this, it's covering almost 1, 2, 3, 4, 5, 6 blocks. Each block has a value of 1 volt. So 6 into 1 is 6 volt peak to peak. This is a V out or a V naught. So note down this voltage in a given tabular column as 6 volt peak to peak. Now we have finished the circuit connection of a op-amp based non-inverting amplifier, and also we have noted the input voltage and output voltage readings in a given tabular column. Based on those readings, calculate the practical gain and theoretical gain.
At MSR UAS, we spark your imagination unlike any other.